As you may know, besides JavaScript, TypeScript and Golang, we have yet another programming language in our tech stack to define our Terraform configs, and it is called Jsonnet. Jsonnet is a strict superset of JSON. It is a DSL that helps you define JSON data, and it is a purely functional, prototype-based, object-oriented language. It was written by Dave Cunningham from Google, and as far as I understand, they use it a lot for Kubernetes configs. And from this discussion on Kubernetes mail list, it looks like Kubernetes community is converging on Jsonnet as a default language for Kubernetes configs. So in this talk, I'm going to talk about this little language. I'm going to show you some of its features, discuss some of its properties. So let's start. As I said, Jsonnet is a JSON superset, so let's take an example object from json.org example page and run Jsonnet on it and see what it does to it. And it did nothing except that it predefined it a little bit. So in the original object we had a mixture of spaces and tabs, and here we have only spaces. And also Jsonnet reordered fields in alphabetical order, so if here we have a ref somewhere in the middle, here a ref is on the first place, and this makes diff tools easier to use. So if you don't use any Jsonnet features, you can use it at least to predefine your JSON files, and also it validates JSONs. So for example, if we delete this comma and run Jsonnet command again, it says that it expected a comma before the next field. So if you give Jsonnet an incorrect JSON file, it will error out. And actually, it does not work the other way around. So if any JSON file is Jsonnet file, any Jsonnet file that uses some additional Jsonnet feature is not a correct JSON file. So for example, Jsonnet allows you to use local variables, and it obviously is not a valid JSON file. So all Jsonnet syntax was built the way that it will break JSON parsers if you will try to use Jsonnet files with JSON parser. So here we have an error. So it is safe to use Jsonnet files, and it will not surprise your programs in any way. In Jsonnet you have all the same data types you have in JSON: objects, arrays, double precision floating point numbers, strings, booleans, null. Of course you can use nested structures. So if we run it through Jsonnet, we get the same object here. In Jsonnet, quotes for fields that are valid identifiers are optional, so we can delete these quotes here and here. Let's add another field so we can see that it actually works. And run it again, and here it is. So we can delete these quotes because nested space structures is not a valid identifier. We'll have to wrap it with quotes. And Jsonnet allows you to put commas after the last elements in objects and arrays, and I highly recommend to do it always. And let's add another field here, run it again, and we have the same structure here. Besides double quote strings, you can also use single quote strings, and double and single quote strings are interchangeable. Also, these strings can span multi-lines, and in case of double quote strings and single quote strings, Jsonnet preserves all new lines and whitespace prefixes. And if you want to strip them, you need to use triple pipe strings, in which case Jsonnet strips whitespace prefixes. There are also verbatim strings, in which every character is processed literally, and Jsonnet escapes them automatically. So if we run it through Jsonnet, we get this object. So as you can see, double quote and single quote strings are identical, and multi-line strings, this string is this string, and new lines and whitespace prefixes are preserved, and in this case they are stripped. And verbatim strings, you see that Jsonnet escaped all symbols automatically. To format your strings, you can use string concatenation like on this line, or use string formatting, which is compatible with Python's printf style string formatting. So if we run this file through Jsonnet, we get this array. You can also use all familiar arithmetic operations, comparisons, bitwise operations, shifts, and operations on Boolean types. So in this case, we get this array. In order to avoid repetition, Jsonnet introduces $sign operator, which refers to the outermost ancestor object, and self keyword, which refers to the current object. So in this contrived example, we have a small library with publishers and authors objects, and books refer to those objects using $sign operator. So this refers to this object. And pub date of translated book refers to the pub date of original. So self here is this object, and self original refers to this value. And at the end, we have a list of books we read and a list of books we have yet to read. So if we run Jsonnet on this file, we get this JSON, and you see that places where we used $sign operator and self keyword were expanded with referenced values. It's worth to note that array in Jsonnet is not an object, so you cannot use $sign operator to refer to the array itself. Jsonnet says that no top-level object found. Same thing with self. Can't use self outside of an object. And if you have an object inside an array and you refer to $sign here refers to this object. It does not refer to the array. So B here is 2. It refers to this value. In Jsonnet, you can define local variables using local keywords. So for example, let's assign 10 to x, and semicolons are mandatory. It's an error if you forget it. So if we output x, we see 10 here. And actually, you are not limited to top-level variables. You can define them in an object or an array, but you need to change semicolon to comma. So Jsonnet outputs this object in this case. And if you have a deep nested structure, for example this A, B, C, D, and if you need to access somewhere down the line a field value of an ancestor object, for example in B object we have x equals 4, and we want that value in this D object, we can use $sign operator to access it this way. And of course it works. We have 4 here. But in real life it can be tedious to remember the path to the value from the root object, and it may be much easier to save reference to the object you're interested in using self keyword and then use it in the descendant object. So let's change this x value, and it's changed here. And this B reference can be accessed only inside this object. It's not available on this level, for example. Unknown variable B. So scope and rules are familiar. Another awesome feature from Python is list and dig comprehensions. For example, if you have a list of numbers and you want to get a list of squares, you can do it this way. So we get a list of squares. And you can do the same for objects. For example, x multiplied by x for x in nums. And actually we'll get an error now. Field must be a string, got double. So Jsonnet builds on JSON, and in JSON fields must be strings. You cannot use numbers as field names. So we need to convert numbers to strings like this. And now it works. Also, you can use filters in comprehensions. For example, if we want to use x values that are greater than 5, for example, greater or equal, then we use it this way. And we don't see 3 anymore. And same thing works for list comprehensions, of course. Same thing here. And for example, if you have 2 lists of numbers and you want to iterate over both of them simultaneously, you can use 2 loops in comprehensions. So x multiplied by y for x in nums for y in nums 2, and it produces this array of 16 elements. So I said simultaneously, it does not iterate simultaneously, of course. It's basically the same as, for example, if we write it in Python, it looks like this. So we iterate over nums, we iterate over nums2, and then we append this value to some list L. For example, we have this. If you need to get a subset of array values, you can use slice syntax. So for example, if you need to get the first 2 elements of this array, you can use this code and it outputs just 2 elements. And in Python also supports negative indices, so in Python you can also write this to get the last 2 elements. So in Python it outputs 6 and 7, but Jsonnet does not support it, so you need to use standard library length function to get length of the array. And now we get the last 2 elements. So when you omit both start and end indices, you get the same array, you get the original array. So start defaults to 0 and end defaults to the length of the array. And there is actually another one index here called step, which by default equals to 1. So if we omit it completely, it gives us the same array, and if we set it to 1, it does not change anything. And if you write 2 here, for example, you get values 1, 3, 5, 7, which indices are, so when we get 1, 2, 3, 5, 1, 3, 5, 7, we get values from the array which indices are 0, 2, 4, and 6. So basically step means by which value it needs to increment start index to get the next value out of the array. And if you change it to 3, for example, and we have 1, 2, 3, 4, 5, 6, 7, we'll get 0th value, then 0 plus 3 is 3, and 3 plus 3 is 6. So we'll get 1, 4, and 7 in the output. Alright, so I was correct. To concatenate 2 arrays, you need to use plus sign operator, and in this case it outputs just 1 array. And this syntax works for objects too. For example, if you have 2 objects and you join them with plus sign operator, Jsonnet outputs just 1 object. And if both objects have field with the same name, the value from the right hand side object takes precedence. So in this case, b value in the output will be 4. Here it is. To define functions in Jsonnet, you can use function keyword. For example, let's define sum function that takes 2 parameters and returns their sum. And don't forget about semicolons once again. And if we call it with 1 and 2 parameters arguments, then we get 3 in the output. And in Jsonnet, functions are actually closures, and if we have x here, we have access to that value in the function, so now it will return 13. Besides defining functions on the top level, we can define functions in objects. So let's move our sum function to output object, and instead of equal sign we need to use colon, and we need to delete local and change semicolon to comma, and let's use it. We need to use self to reference sum, and if we run Jsonnet on this file, we'll get an error. Couldn't manifest function in JSON output. So JSON doesn't have concept of functions. Jsonnet can't serialize a function to JSON, so we need to delete it once again out of this object, or we can hide it. So Jsonnet does not output this field to JSON file. And to do it, we need to use double colon here. So now, if we run Jsonnet, we get this one field object, and sum field is hidden. It does not get into output JSON. So this is one way to define define function in an object, and there is another way. We delete function keyword and move parameters here. It is a much shorter way to define a function. Let's get our application back. Self.sum 1, 2, and if we call it, let's change values. 4. So 4 plus 2 plus 10 is 16. We need to get 16 here. Alright. As you remember, Jsonnet is a prototype-based object-oriented language, and here we have a simple hierarchy of objects. Animal object serves as a prototype for other objects, and it has same method, which returns a string with animal's name and how many legs it has, and some other objects override same method, and they use super keyword to refer to parent same method, and they concatenate parent same method's return value with an additional string. At the bottom we have an array of objects, and we call their same methods. For this object we just use this object directly, and for other objects we instantiate additional objects and give them names, and then call same method on those new objects. So if we run Jsonnet on this file, we get an error because we attempt to use super when there is no super class. So the error is on the 22nd line. It is here. So obviously Octopad does not have a prototype, so super does not refer to anything, and we need to fix it. So octocat is Octopad, and it should also be a cat. So let's add cat here. Let's do it one way first. Let's add cat after Octopad, and it does not work correctly, of course, because we see that bunny has 4 legs, though it has to be Octopad with 8 legs, and it does not show us this emoji here. So let's move cat to the first place. So octocat has same method from Octopad, because right hand side values take precedence, as you remember. And if we run Jsonnet again, we see that bunny has 8 legs, and it is cat and Octopad simultaneously. So I want to note that if you join two objects and the right hand side object is an object literal, like here, you can omit plus sign and it will work the same way. So it just looks better without plus signs. And we can't delete this. We can't delete this plus sign because right hand side object is not a literal, so it won't work. I ran Jsonnet and here we get the same output as before, but if we delete this plus sign, it will give us an error. So let's get it back. Jsonnet is a purely functional language, and there is no way to change anything. There is no way to mutate anything. So if we define a variable and assign an object to it, let's output it, and there is no way to change it. You can redeclare a variable, you can assign a new object to the variable, but the old object is still the same. Let's assign it to a new variable and output both of them. So f is an old object and b is a new object, and an old object is not changed, and you cannot change it. You cannot write something like this. It's an error. It does not matter what you try, it just doesn't work. And if you really need to update an object, you have to create a new one. That's the way how it works in functional languages. So you create a new object, and here we have that so-called updated object, the new version, but the old one is still the same. And you have to assign to a new variable. You can't do something like this. It does not work. Okay, let's fix, we don't have f variable anymore, but it still does not work because max stack frames exceeded, and because this d does not refer to this object. It is not the same. It's not this. It works this way, but it does not work this way, because this d refers to this variable. It's a recursive definition. So if you need to update, if you need to create a new version, you need to define a new variable. And it is basically the reason of why all data structures in purely functional languages are persistent. You just can't change old versions.